Uh, Hello, everyone. Thank you for taking your time to join us today. Like I said earlier, I'm actually always excited when people come out to hear me talk. I'll quickly share my screen to kick off this session. Um, would you be able to enable me access to share, Babatunde?
Can you send the request? I'm here to get the request. I think if you're able to send.
Uh, I doubt it has given me that option. Actually, it doesn't give me that option.
One
It
second.
says it's been disabled.
Uh, mm, One second, please.
Right. What is a good tech meetup without some technical difficulties?
Hmm. But I do. This is funny. Open on settings. Sure. I think you should be able to send the request. One second. Mm, Sorry, everyone. I'm trying to see where to enable you again. Those tools. Share. Okay. Can you try now, please? Okay. Okay. Thank you.
Hello, everyone. I believe my screen is visible now, although we'll get the whole infinite loop thingy that happened. So just to buttress on what Babatunde said earlier regarding the JetBrains license, they do offer a range of tools for various programming languages and also some product management tools. I believe that's Team City and UTrack. It is, for lack of a better word, an amazing product. JetBrains, the entire ecosystem is amazing. So if you do opt in for any of the licenses, do give them a trial. And to go on to why we are here today, we're actually not here today for me, but because I will be talking about what we are here today for, I'll tell you a bit about myself. I'll go with who I am community-wise. For the past couple of years, I'll say 2, 3 odd years, have been a very active member in the .NET community in Liverpool here, where I co-host a .NET organization, meetup, basically, monthly meetup. We basically try to get engineers all around city, the city to basically come around, talk about themselves, talk about work, talk about what we find all collectively find interesting, which is technology. And basically, it's fun just doing that, being a place outside work. It's one of the communities I basically engage with. During the weeks, I work at Volkswagen, where we do a couple of fun stuff around finance for vehicles, basically. But the most interesting part about myself is my very interesting relationship with creativity. I love creativity in all forms. Books, paintings, music, the whole shebang. But I do not express creativity by creating any of those. I unfortunately am only able to consume at the moment. But how I do explore creativity at the moment is software systems. It's a very exciting version of creativity that I found myself like deep dive all the way into. And to be honest, that's me in a nutshell. I'll go on to the interesting bits why everyone is here today. Microsoft's agentic framework. Um, so before I go into the whole dang or shebang of what Microsoft's agentic framework is, I would like to my whole idea around technology is always driven by okay, why do this before going into the what. So before the whole shebang of what it is, I'll try to give a small history and conversation about why we do it. And the entire reason why we do it are agents. And those are like the most interesting things. So basically, what are these agents? Why should you even be interested in agents? Why everyone goes agentic apps these days? This is agentic. This has AI in it. This has a. This is made from. This made with is AI powered. etc. etc. But what are they? So recently, over the past couple of years, we had a proliferation of accessible. That's for lack of a better word, accessible LLMs in the industry, and this gave rise to something that has been for a long time missing, the ability to build software products that don't rely on very strict rules, very strict instructions, and perform a task that gives you very, I wouldn't say accurate, but as close to accurate as possible, a fuzzy response around what you want. So I'll give like a distinction between traditional software and what LLMs enable us to do. Traditional softwares, you go um 1 plus 2 would always give you 3. You go 3 plus 5 is always 8. Those are like the instructions you expect. You expect a definite input format and a definite response. And when you don't get this sort of input or you don't get this sort of instruction at the boundary, you reject that entire process. You're not able to automate that process because without precise, clear instructions, you don't know how to handle that process. You're not able to pass that through the set of rules you've put on a downstream process. And that's where LLMs come in. LLMs help us with a very interesting take I heard about last month. It helps us with the question of from those rocks there, can you give me a little one? Or from I just need some water. In this context, there's no definite answer to the concept of little rock or small rock or some water. Um, it's based on perspective. It's not 15 kg is not a small rock when there are rocks in the sample space of 150 kg or thousands of kg. But 15 kg is actually also a small rock, could also be a big rock or a small rock depending on context. And you could basically try to calculate all of this, give up rules as to if the context is this, this is the definition of small, this is your definition of small, that definition of small, etc, etc. But why do all that when we have the beautiful tools of LLMs that give us what I'll best describe as fuzzy answers or fuzzy responses to instructions where you go, I need information about this given this context, and you get close enough response in a close enough processable input for that query. So say you say, from this pool of rocks, can you give me a small rock? And then you estimate, that's the word I was looking for. You estimate that from this pool of rocks, today a small rock is actually that particular 5 kg rock, and tomorrow is actually the 5,000 kg rock. And that's what LLMs help us do. They help us um assume autonomy. So unfortunately, it's not the exciting type of autonomy we get with Navies from um Iron Man, if you watch if you're fan of the MCU, but it's the autonomy where we have a fuzzy boundary between input and what we process. And what's also makes that extra exciting is then we enable when we enable said tools or said fuzzy tools to also be able to perform actions based on context. So where I need to get a fuzzy rock. How do you determine that there is a fuzzy rock? The first thing is to find out that what the sample size is, what the parameters or what type of rocks are within the context. And said tool is within a single instruction or a single processing pipeline able to determine that within this context, there is no definite definition of small. So what do I need to do? Try to find out what small is. That's like asking back what small is. This is not the automated bit, by the way, but being able to determine the automated bit or the part that does make it agentic is being able to say, oh, I can't actually ask a question back to the user. This is can actually ask a question back to try to get more context, or within the context I have, I'm able to perform action. Within this context space of get me a small rock, I'm able to measure the size of all the rocks in the environment and come about an answer or a resolution of what you want. And that is what we have today, agents, reasoning tools that basically tools that take in unstructured inputs, um, gets as best an estimate or does its very best to get you a response, and it does it very fast. So you're not spending thousands of hours processing. It does do it fast because of like GPUs. Obviously, you do spend a lot of money. That's why it's like super expensive and whatnot. So that's agents in a nutshell. LLMs and the ability to perform actions with context, within the context that they are operating. But it sounds all exciting. It would be very exciting to be able to wake up one day, get an LLM, and make it a software product, because this is a beautiful tool. It does what software is meant to do. Um, Make a very manual process and automate it as best as we want to do. It's not really a software product. Because as much as we'd like it to be, your tools like ChatGPT doesn't go in the background, and it isn't actually in real time do any of this information. The ability to do all this is an amalgamation of so many pipelines, so many orchestration layers, so many boundaries, where you're able to, in for each particular iteration of a workflow, you're able to store states in between. You're able to know, oh, the last time the current problem I am solving is what is a small rock. Even though at this moment I am solving the problem of what are the sizes of rock in the sample space, the current problem I am solving is what is a small rock. And even when it solves that, we are able to, this is me giving a sample with ChatGPT as like a problem space. Within that context, we're able to like retain history. So when you ask what is a small rock, historically, or give me a small rock from the sample space, historically, there's context that you said user or said sample space has been processed previously, and we don't go through the whole process of trying to make tool calls or make actions or activities off the back of that, because we have historic context, or even, or we're able to, within the context, we already knew what the sample, again, we already know what the sample space is. Um, we are able to minimize or isolate the problem, solve exactly what we are solving with the best context of current situation of what's happening at the moment. And that's being able to manage state, because that's what a software does. That's how it simulates the idea of autonomy or the idea of intelligence, is retaining information. That's how we humans exist as well, because we retain information or we action on context of what's happening at the moment. Same with process continuity, being able to execute across different stages. It's not a single request that goes um I need this information, or I'm trying to perform this action at the moment, and when that action stops at any point in time, then you're not able to do any other thing ongoing. But it's sort of like an integration where you're able to begin an action, continue at a later point, carry it on at a later point, then etc. And some other important things that that are very important for any software product. One is monitoring. Any software product without visibility is it's going to be a big pain. There are lots of reasons why you do want visibility. There is compliance reasons, there is audits, there even knowing the cost of your product, knowing what particular process or what exactly is happening within your product, because software is not a black box. Um, it's a very visible product, I would say, where you need to know both the cost, failure surfaces, what's gone wrong, where it goes wrong, what exactly is happening behind the scenes to make that product work. And the most important thing is security. If you do leave that part out, you are basically building a product to um, throw money away in different ways. You are serving real clients, and real clients do pay money for those activities. And there are loads of people that do want your clients' money and your money as well. And loads of people that want to use your resources or for some reason just make your products unavailable. And these are what software products are. The difference between an LLM or an agent and a software product is having this tidbits, there's little tidbits of capabilities that take them from being a garbage in, garbage out to actually being a reusable software product. And that's where we are today. Microsoft's Agentic Framework is a framework that's designed exactly for that, to bring us from point of LLM with capabilities to product that's a tool that you could use to develop a software product with LLM capabilities. And before I go into Microsoft Agentic Framework, it's a bit interesting the historical evolution, I would say, of Agent Framework for Microsoft. So Microsoft initially introduced the semantic kernel and AutoGen. Semantic kernel was a beautiful library, or is, it's not was, it still is a maintained product, is a beautiful library that helps you do something very important, which is integrating LLM capabilities and in-process running of functions or methods in your application, in your enterprise application. So the boundaries or in between different business processes or application processes that happen through semantic kernel, and that part of the driving forces on in the integration of semantic kernel was the introduction of the MCP protocol, like the MCP, the model context protocol, where a single model LLM had context to both memory, ability to perform actions, in process actions, and be able to like integrate basically into an enterprise application. And like another iteration of that was the AutoGen. This was developed basically alongside semantic kernel or alongside semantic kernel. The AutoGen is a tool that was developed with a focus on research. So it was like a multi-agent research tool where you try to get improved, or its idea or design idea was an attempt to get improved results by isolating both context, solution landscape between different LLMs with isolated instructions so as to arrive at what I would call an optimal response. So I'll give you an example again with my favorite example, ChatGPT. You go on ChatGPT and you try to get the response to a certain problem. You go, what is a stone? And it says, or rather, give me a small stone in from this sample space. And it says, oh yeah, so I'll do that. And it comes back with what you don't consider a small stone, and you tell it, I don't really think that's a small stone, but or rather, that's what you brought is the smallest item from the pool. But that's not actually a stone. That's more like a rock, or that's not what I'll classify as a stone. And then you go in a back and forth process where you're trying to optimize responses to arrive at what or your target. And you're able to do that with agents, basically, where you have agents with different instruction sets, different tool sets, different contexts as well. And they try to communicate between each other. So it's like a request response back and forth communication with a state flowing through that communication. And they try to arrive at a solution space, an optimal solution space, whatever it is, an optimal solution space. And these two libraries gave birth to what we know today as the agentic framework. The agentic framework is the best of both worlds. and more actually. The best of both worlds and more. It's integration of both the MCP capabilities, agent interaction alongside enterprise tooling that enables you to inject this very easily into your application. So I'm talking about middleware, security guard, auth, you're able to monitoring as well, telemetry. You're able to have context providers, pluggable context providers. That's the key part where you have abstractions on your context or memory providers, and you can implement it however you want. You want distributed memory store. You want your memory store to be a vector database. You're able to do is you're easily able to implement stuff like RAG, etc. into your agentic workflow. And in order to do this practically, I'll be walking through a couple of options you have with the agentic framework on how to integrate this in your enterprise application. First would be what I'd call structured outputs, or what I'd call the building bone or the foundation of the agentic framework and the semantic kernel as well, something that makes all the difference, and that is generics. Um, this is an example of a travel planning application where we have interaction between an agent and some in-app processing, as well as a different agent that makes some other processing before we arrive at a response for a user. And why are generics beautiful? Because we could do the very beautiful thing of running an unstructured input or information and enforcing a structured output. And for any software engineer, this is key in the software process. You recall when I started this talk, I spoke about um, part of the reasons why LLM excels so much in the field being able is the ability to have a context, the ability to receive unstructured information and respond to it and to be able to process it within a structured processing pipeline. And that is what the agentic framework does for us with the structured response. You are able to receive very unstructured messages from users. You determine and you process that into a very programming programmable interface or programmable contract. You're able to interact with that through any pipeline. This is like the most basic of pipeline. You process that inline as much as you want, and you could also hand that response or forward the response, process that with another agent, gets you a very structured response and process it any other way you want. The second bit of tooling we have again with the agentic framework are the agents with tools. And this is like a very beautiful one. It is part of what the whole the MCP model context protocol is a bit funny calling it an MCP protocol when it means when it's actually MC protocol, but yeah, model context protocol. Um, that's what the agents with tools do. It's basically exposes um running in-app processes to an LLM. So, and it's not just exposing that, but managing that context for you. So the entire idea of having an LLM know it has the ability to measure stuff, calculate stuff, or read from here or perform an action. It knows that, but it's not able to do that. The actual thing making that decision or the actual thing making that interaction, the actual thing that actually processes that action is your application. So I've done like a little diagram of how that entire interaction works. The only part you actually manage is sending a message, passing the capabilities with the tooling, and then you get a response. The agentic framework takes care of managing all the in between for you, and this is a single tool call the agentic framework can enable you make this tool call multiple times, manages the entire process of keeping states, context, or determining which process is wrong, passing the process back to the LLM for a decision on next step. So how does that work? You send in a message through an LLM. LLM reads the tool list schema and says, oh, I have the ability to do one, two, three, four. Oh, maybe do three for me. I want you to be able to perform three for me and tell me what the response is. And then it sends that to your application runtime. Your application runtime performs that call, returns the result to the LLM. The LLM sends that back to you. The LLM processes that and generates a response for you and sends that back to you. And all this shebang in between is handled by the Microsoft Agentic Framework. How do you wire that in? You use the little AI function factory. It's a factory with the double named thing is it is a factory, AI function factory, able to create tools. And beautiful thing about it is it works very beautifully with your IOC container. So this is the Microsoft IOC container, but it does work whether you're using AutoFac or any other IOC container. You're able to provide in-app runtime methods or actions to an agentic call, and you get that capability of processing those actions while or the agent or yeah the agent the LLM determining to process those in process actions and arrive at a desirable response for your application without you having to manage all that context. The second thing, or the third um, pattern or way this framework helps is something called agents as tools. So we just discussed earlier about the passing in tools to agents and how that works by passing in a schema of the capabilities of what those tools are, etc. to an agent, and then the Microsoft Agentic Framework runtime. But the parts we shouldn't gloss over, at the end of the day, we are engineers and we build to optimize, not spend um millions in trying to create a single application. um, Going back to our previous context, we send in a single request to the agent. Where are the files in my how many files do I have in my directory? Or can you I'd like to say part of your working process is creating a new file per user. To-do list, say you're creating a to-do list and you create a new file per the user list created, and then you send you try to get an application to, oh, I'm trying to go to the market next week, could you create a to-do list of stuff I'll need to buy in order to set up a home studio. And then the instruction goes on to the agent, and then the information the agent gets I'm able to create files alongside your information. Say your message token size is 500. Alongside your information, what the agent gets is I'm able to create file, I'm able to delete file, modify file, and this is how I do it. And the total token file you get sent is 1,400. Which trust me is a lot of money, and you're going to run out of money very quickly. The advantages you get over the LLM integration begins to diminish very rapidly. So one of the ways you could combat that reliably is something we call agents as tools. So with this particular pattern, you're able to create focused agents that have the ability to perform a minimized set of actions. So you're not just passing all capabilities of actions in your application to a single agent. You isolate this into modular units that perform similarly related tasks basically. And what does that do for you? You have a message size of 500 and you have a multi-tool agent that takes in, say, 200 watts of token or even 300 watts of token. Just by modularizing, you have reduced your token core size to about 600, 500, 1,100. You saved yourself about 300 tokens in cost, which is a lot. And this is actually a an estimates. Basically, the token reduction is actually a whole lot because an initial agent basically does is routing. It takes in your user information. It has information on what each agent is able to do, and all it does is it routes to the agent that has the capability to perform that, takes in a response, routes to a different agent that has the capability to perform that, and then gives you back a total response. And I'm guessing we cannot appreciate how helpful that would be. To set that up, you basically are able to do the exact same thing as passing on tools to the agent because of how the agentic frameworks, contracts and APIs work. It's as easy as creating an agent and um, accessing the extension method as AI function, which converts that agent into a tool that you can pass into your list of tools. Oh, last time I did this talk, one of the feedback from the people was there was no comic relief in the talk, and this is my comic relief. So if we take like 5 seconds to laugh a bit, wow, roll on to the next talk. Moving on from so everything we've spoken about before were manual integrations, not exactly manual, but there was zero the agent-to-agent communication was basically limited to tool orchestration or tool management. But then there are other instances and also manual orchestration and tool management. But you could build agents. I mean, there are many ways to actually build agent orchestrations. A different one or a different pattern is the rule orchestration engine. And if you've used any orchestration engine before, this will be like a very familiar tool for yourself. That's how easy they've made the API contract. You're able to build individual or unit nodes in a pipeline chain. And each of those nodes could either have an agent at that node or a manual processing. I keep calling manual, but software is not really manual, but yeah, a manual processing node that takes in different steps in your pipeline to arrive at a result. I'd give an example. A very good example here is trying to build a workflow for determining a country or something, I believe, for this. So basically, there are lots of other executors on here. These are like different nodes in your pipeline, and you basically create a graph as to it is a graph at the end of the day. You basically build a graph of your pipeline or your workflow. You start with a source node in your workflow. You're able to add edges to those nodes. So edges will be stuff that's run in parallel, I believe. Not in parallel, edges like passing it down, but you're able to add a switch as well where you have a decision. You either take a decision on do this or do that. And if I quickly exit from this, I'll show it a bit more clearer down here. So this is an example of a reflecting executor. Um, this does quite a couple of stuff. This is a node that does country extraction. I believe it does that with an agent. This is something that checks from your cache if there's a previous response before executing some of the yeah, before executing the data enricher. It basically is a cache layer in between and then formats the message at the end of the day. And beautiful thing is you're able to add switches. So switches are like decision nodes where you can determine to run one you can determine to run one branch or a different branch based on the condition, same as edges. This is just like a single do this next type of branch, and you're able to arrive at a decision. And one of the beautiful things about the agentic framework that I highlight in this is it gives you two ways of running an agentic workflow. It enables the first flow we had discussed earlier with the generic immediate give immediate results pattern. Um, handles the entire execution process of the workflow for you. You're able to hook in pre-execution, but not during the execution process. But you also get this wonderful tool, the in-process execution tool that basically enables you hook into a workflow execution. So what that means is during the life cycle of the workflow, you be able to hook into its life cycle, hook into different events, if it's a completed event, or you're able to hook into if it's for a particular um, node in your workflow or a one event or a different type of executor events you could hook into to
Sorry, something. I think you're
determine.
breaking.
Mhm. Is this any better now?
Yes, yes, it's better now. Thank you.
Perfect. All right. So that was a good time as well. Last but not the least are the multi-agent workflow orchestration. So this was like the one of like the most beautiful tools in the agentic framework V1. This is basically almost similar to the earlier reflecting executors, but the only difference is you have automated contracts that enable you to determine agents. So this is more related to agent workflow rather than agentic workflow plus manual workflow. So this does sort of like orchestration between agent to agent interaction, reminiscent of A to A, reminiscent of autogen. So it is A to A, agent to agent interaction. There are like different strategies you could follow with this. And I've given an example with handoffs. With handoffs, you're able to determine which agents can talk to which agents basically. So say you have a root agent, an orchestrator agent that has access to that is basically the root agent in the workflow. With this particular wiring up in the tooling, you determine that this orchestrator agent can only talk to the location agent and the weather agent. You receive the orchestration agent receives an instruction. It determines if it can solve it itself or you're giving it an instruction never to solve itself, but to delegate to other agents. It basically determines if it's going to delegate to the location agent or the weather agent, but it's never going to delegate to the weather agent. And then with this, you're basically telling the location agent and the weather agent that they are only ever going to respond back to the orchestration agent, meaning this fella here kicks off the workflow to either of these, and either of these can respond to him. And then this fella also can translate the information to any determining language and give that response back to the user. You could also do the human in the loop process where the agent is able to receive response back from a trigger human interaction. Yeah, it could be HTTP. There are many interfaces built in for that where you need a manual response to proceed in the pipeline. And yeah, so that's like the beautiful thing about the um agentic workflow execution. The last but not the least, I'll be talking about durable agents. If you are familiar with durable tasks in Microsoft Azure, durable tasks basically help you run long-running processes in serverless nodes. So serverless nodes have the limitation of having a maximum amount of time they could run for. But with durable tags, you're able to perform many, it's basically an orchestration engine on its own. It's a node orchestration engine. But with durable agents, you get all the advantages of durable task orchestration, having multi-branching activities or orchestrators, etc. And we also have the beautiful plan of them actually being agents. So the entire workflow strategies I had mentioned earlier, handoff, the magnetic workflow, or human in the loop workflow, etc. You hand the entire in-process handling that I just described earlier. You could literally handle them as um, serverless nodes. So this is bringing single machine, single node processing to extremely scalable processing. You're able to process millions and millions of tasks with um, orchestrated agent pipelines using the durable agent. I haven't set up a demo for this because Azure has a very beautiful sample for durable agents with a travel planner as well. If you do want to check it out, there is a link to that. And oh, that went by very fast. Thank you, everyone. If you do want to, okay, let's just go with questions first. I would go off from this, stop sharing my screen, and ask questions. So if anyone has questions for me, I'll be happy to take those.
Thank you so much, Samson. This is a good one. I've gathered a few understanding about this durable agent. I think I'm doing a bit of work on something regarding agentic commerce. I can basically integrate some of these things that you've mentioned. Thank you so much. Uh, I don't know if there is any question. You can as well ask something. If it's possible that you might have question that is not related to this topic regarding AI or agentic, you can as well ask. You can also be able to answer your question. Yeah, let's just see if there is any question. Thank you. Okay. Okay.
So
Thank you.
I would not take this as a good sign or a bad sign. But anyways, I'm actually really grateful to everyone that made their time to come listen to me today. Thank you also for inviting me to speak with your community. Hopefully we do get to do this physically sometime.
Yeah, sure, definitely. Uh, Later this year, we're going to organize one in Lagos, and hopefully, you can come down. I think we just plan it. I
I'll,
understand.
I'll give you my best,
I
to be
understand.
fair. Well, thanks everyone. Enjoy the rest of your day, guys.
Thank you so much. I'm going to do based on this name and the people that joined. I'm going to do a draw later, and anybody that when the license, I'm going to post it on the meetup link so that I can send the license to the person. Thank you, Samson, for this wonderful presentation. Thank you for joining us. We're going to do another session next a month. It's a monthly thing, so we're going to do another session next month. Up to then, please keep building, keep improving, and I believe the next solution might become from you. The next unicorn might become from you. Thank you so much, everyone.
See everyone sometime later. Bye now.
Bye. Thanks. Thank you.